Habib, are you
Yes,
there?
yes, I'm here.
Okay, you can go on with the presentation. Let's start. I don't know to fine.
Okay, good morning, everyone. It's nice to be here this morning to discuss one of the challenges we are having so far in Nigeria and most especially in the world in general. Because in Nigeria, we actually rely on hydro energy and other forms of energy, which results to some carbon emission. So today we want to discuss about clean energy itself and its components. So I will share my screen now for us to see the walkthrough on the presentation. Okay, just a second. Okay, I believe we can all see my screen.
Yes, we can.
Yes, sir, we can see it.
Okay, thanks everyone. So the topic is all about clean energy and its components from the word clean. And yesterday we presented a topic on electric vehicle in which we discussed a few things about clean energy itself. So today we are just going to look at clean energy and all its form with its components. So about me, I am Bilu Habib and my area of specialization include AI, brain computer interface, embedded system, and blockchain tech. So the outline for today's presentation include that is, after this presentation, we are expecting you to understand the need for clean and renewable energy, to identify the various types of renewable energy, to classify the solar technologies and type of PV system. So what do we mean by this PV system? It simply means photovoltaic system. To identify the basic components of the solar PV system, to understand the functionality of the component, and to understand how to design an off-grid solar system. Because we believe that this presentation will give you some insights about how you can also set up your off-grid solar system. Because there are a lot of people that want to go into solar system, they want to have it at home, but um, they don't have the light on how to go about it. So this presentation we actually help on that. Okay, so now we need to understand the need for clean energy because we have been using some energy before. We have our generating sets, and most houses use this generating set, but have some challenges. Okay, let us take an instance. If we have fuel scarcity, then it simply means that we cannot power on our device at home at the rest. So in this case, we need clean energy. So now the next slide is all about we need to understand the need for clean energy. But before we look at the understanding of the clean energy, we need to understand the word clean itself because we have different form of energy. But I would like to take us a brief on some physics terms for us to understand better of what energy is all about. Fine. So if we are talking about energy, we can say in basic terms, energy can be defined as the ability to do work, which is the ability to exert a force causing displacement of an object. If there is no energy, so it simply means that the rate of our work will reduce. So if there is no energy, then it simply means that we will not have the capacity to do some work. So now from this, then let us now see how it is related to the word clean energy. Okay, so if you are talking about energy, we have different types of energy in which we have discussed in our basic science, in our physics, and in chemistry. But we need to do a recalculation about it. So if you are talking about types of energy, energy can be classified into two, in which we have the potential energy and we have the kinetic energy. But the kinetic energy is inherent due to movement, motion, or action. I want us to take that again. Kinetic energy is inherent due to what? Movement, motion, or action. But potential energy is inherent due to position, the status, and properties. Okay, so now let us now look at the examples of energy. So the example of energy include light energy, heat energy, mechanical energy, gravitational energy, electrical energy. sound energy, chemical energy, nuclear or atomic energy. Okay, so now if you look my slide, I have a part in which I have already what classify it into two with their example. So for potential energy, we have the chemical energy, we have the stored mechanical energy, which is a form of a catapult. Then we have a gravitational potential energy, a stone on a hill. Then we have a nuclear energy. So for kinetic energy, we have electrical energy, radiant energy, thermal energy, motion energy, and sound energy. Okay, so now we still need to look more into energy itself. So for potential energy, um as you can see on my slide, we have the nuclear, the electrical, the elastic, the chemical, and the gravitational. And this energy also give birth to kinetic energy, in which we have the electrical, the sound, the thermal, the wind, and light energy. I think there is a slide that I will use to discuss more about each of these energy. But for the sake of this presentation, I will focus more on solar photovoltaic cell. That is solar PV, because that is the most common used form of energy we can use to subsidize for our hydro energy. Okay, so now let us take an overview of energy. So now the first question that we want to attempt here is that what form of energy is the most important in today's world? That's a big question. And when you look on my slide, we can see that this is what electric energy. We use electric energy at home, and electricity is one of the major energy that we concentrate on. That is, if we do not have this power supply or we do not have this electricity, it becomes a problem for us. We start looking here and there to find a solution to it, because we use electricity to do some major things at home, like our air conditioning, our lighting, our water heating, refrigeration, television, space heating, clothes dryers, our computing, computers, and the rest. So all of these all focus on electric energy. Okay. So now, just a second. So now let us look at how we can generate electric energy itself. Number one, we have the generating set, small generating set, as you can see on my slide. That is Tiger generator that we use at home. We have the big generating set also. We can see these at companies, at in our schools, and big companies and the rest. Also, we have gas turbine station, we have a coal thermal station, we have hydro dams, and we have nuclear power. Now, the main focus of energy itself, or how we can generate it, all starts with conversion of these some of these mechanical energy to electric energy. Let us give an instance. The hydro dams that we are setting up, I believe that people that they are here, most of them, people that they are here, not all not all are from the science background. So, but let me just give a very good example that we can get. For all this mechanical energy, what we are just focusing on is what is called turbine. Even if you are using a nuclear power station, you know, from the word nuclear power, it actually comes from what is called nuclear energy. And when you look at nuclear energy, right from the time of Henry Becquerel, in which he discovered the radioactivity, that is, it actually deals with how devices degrade, and as they are degrading, they are releasing energy. So this energy that they are reducing are in form of nuclear energy. So this energy, there are some substances that actually do that. So and part of those substances is what we all know as all these uranium and the rest. So now, but the major thing is that as they are degrading and they are giving out this energy, it should be connected to a turbine. And once this turbine is rotating, then it produces a mechanical energy. Now, from this mechanical energy, then we now have an electrical energy. We now have a generator that will be connected to this mechanical energy in order to convert this mechanical to electrical energy. So that is just the basic idea of how an energy has been generated. Even when we get to our hydro dams, what is happening there is that there is an outlet of water. The outlet of water is to run a turbine. As the water is rolling a turbine, then the turbine is in form of a mechanical energy which will be connected to and electrical energy. Then the electrical energy is the final product that we have at home and we have at various places. So that is just about these electrical energy sources. Okay, let us now look at everything that we are saying here, we can all testify to it, their disadvantages, their the challenges that we should be getting from all these electrical energy source. Let us take an instance of small generating set. For those that they are listening to me, I want some responses concerning this. So what kind of challenges do you think we can have in all these systems that we are having, starting from the small generating sets? I want a response so that I will be able to know that I'm not the only one here.
Personally, to me, Mr. Abib, are you there?
Yes, I'm here.
Okay, the problems I think is actually common to me from the small generating set is the emission of carbon monoxide called CO, because this has a great effect and is very dangerous to the health of people out there. But even though most people don't usually pay attention to it, so if they can be a substitute to this, that will make things more safer for people and won't expose them to dangers. That's my own opinion on it.
Okay, thank you very much for that contribution. Any other person to contribute?
Yeah, well done, Mr. Habib.
Thank you.
Yeah, another challenges that we are also facing is the sound. Most times we have issue of the sound. Sometimes you have to put it a distance away from your comfort zone so that you can be excused from the sound. So if there is a way those generators can be refined without sounds or something in such a way that you'll be excused from the sounds and the carbon also. Yeah,
Okay,
thank you.
thank you very much for that. So, any other contribution?
Excuse me, sir.
Okay,
I I don't know what the first guy said, but my own is that the carbon monoxide, that is the air coming out from the generator, usually gives people problem when they perceive it.
okay,
Like it's XYZ is not okay.
okay,
So
okay, that's
it's
good. Any other contribution?
Yeah, well done, sir.
Thank you.
My own contribution here is I think the general problem that may happen to every one of them is lack of maintenance. How do we maintain those things that will make them follow for a long period of time? Uh,
Okay, any other contribution? Okay, I think we don't have contribution. Thank you so
So my
much. Okay,
my
okay, okay, I'm with you.
my contribution is that the gas that is evolved from generator sets they causes chlorofluorocarbon which deflect ozone layer
Okay,
and cause global warming.
okay. Do we still have one more? Okay, so thank you so much for the contribution so far. So it simply means that I'm not the only one here. Okay, so from what we have discussed, I highlighted four things. The first one is sound, coming from small generating set, or let's call it generating set itself. Sound, because at times we want to work at night. So how do we now do the work? We have to on the generator, and once you on the generating set, people, your neighbor will start complaining and the rest, and even you have to place it at a very far distance for you to enjoy your electricity. That is one. Secondly, someone talk about the carbon emission, and that was the last contribution that we have. The second and the last, the carbon emission that also can lead to what is called chlorofluorocarbon and can result to what is called global warming. Because as this thing is trying to escape to the atmosphere, it actually depletes the ozone layer. And in this case, we have to look at how we can solve this. Okay, that is true. Because don't forget that part of the presentation outline is that each and every one of us should be able to identify why we need clean energy. Okay, so the third person discuss about lack of maintenance. Fine, because when you look at generating sets, anytime you have problem with it, though I believe that people that they are using small generating sets, we also call them small mechanic, because there is no way you have this generating sets and you will not know about one or two things to do. And when you look at it, anytime you have problem, you have to call people to come and do it for you. And once they come, they start giving you different excuses and the rest. So that is another thing. And the last one is global warming. Fine. So since we highlighted these four things, then we now need to look at how do we now solve this. We don't want a spot generating set. We have to remove it. And as we are doing this, don't forget that we are also helping the environment. Okay. Now let us now look at what the next slide is talking about. Because we already identify electricity to be our major problem, right? Okay. Now, challenges of fossil-based energy source. Number one, pollution of the environment, which we have discussed. Public health issues, which we have discussed. Energy security and political concern, which we have discussed. Okay, now let us look at this. Apart from generating sets, there are other form of energy that we did not take note of it. Like you see nuclear power station, hydro dams, coal thermal station and gas turbine station. Not that they are not good, or not that though actually some are not environmental friendly, and whereas we have some that they are environmental friendly. But most of these energy sources require what is called high technical know-how before you can operate it. We cannot just call anyone, maybe someone that study sociology, to come and operate as a nuclear power station. It's going to result to a lot of problem. And once there is an exposure of this gas, it can kills a lot of people, because what it is giving out is powerful, it's harmful, it is poisonous to the environment. So therefore, it require what? High technical know-how. So we need another source of energy that doesn't require high technical know-how, that it is soundless, that it is noiseless, that is not emitting what is called carbon, and it doesn't require these high technical know-how for the maintenance, and that we also solve the issue of global warming. Okay, so non-flexibility in nature and greenhouse gas effect. So after taking note of this, now I want you to pay attention to this. Now, solution to energy issues. You can see this one is part of what? Affordable and clean energy. Now, there is an aspect in which you can also come into play to help our environment and the rest. So agenda 7 discuss about the use of renewable energy and clean energy. So why renewable? Okay, the sources are readily available. That is one, because they are what? They are renewable energy system. The sources are what? Readily available. Let's talk about sun. Sun is what? Readily available. The ease of storage and transport, almost zero what? Emission, no emission. And lastly, economic stability. Okay, so now let us now look at renewable energy versus non-renewable energy. So if you're talking about renewable energy, they can be repeatedly replaced naturally. That is one. They can what? Be repeatedly replaced naturally. Unlike anytime we have fuel scarcity and we have some challenges, then we can't have a power supply. But a non-renewable energy resources cannot be repeatedly replaced shortly. So that is difference number one. Another major difference is that a non-renewable energy resources is limited in nature and cannot be replenished at a scale of consumption. That is two. You know, if you are using your small generating set, not that as you are using it, you are trying is trying to what? Replenish. So that is that about that. The second point. And third point is that while a renewable energy resources can be replenished at the rate of consumption, renewable energy sources do not pollute the environment, while non-renewable energy sources pollute the environment. Let's take that again. First point, it can be repeatedly replaced naturally, but non-renewable energy, it can't. A non-renewable resources is limited in nature and cannot be replenished at a scale of consumption, while a renewable energy source can be replenished at the rate of consumption. As you are using it, then it is what? Replenished. And lastly, renewable energy sources do not pollute. And don't forget, part of what you have contributed and part of what I am having here is that we want to what eliminate maybe either noise pollution, um, air pollution, and the rest. We want to what eliminate that. Okay, now let us now look at this slide for us to have a very clear types of renewable energy and non-renewable energy. For renewable energy, we have solar, which is gotten from sun. We have hydropower from water. We have biomass, which can be gotten from um, products, waste products. We have wind and we have geothermal. Okay, so these are renewable energy that we can also what we can also look into. In fact, there are some hybrid systems that we have now that is the combination of both solar and wind for us to have the electricity. But for non-renewable energy, we have oil, we have coal, we have nuclear. Because, like I said, that if you are working on nuclear, if you are working on nuclear energy, it require high technical know-how. And not only that, they are they falls under non-renewable energy because they can give an emission, and that emission is poisonous. And lastly, we have natural gas. So these are example of non-renewable energy. Okay, advantages of renewable energy. Don't forget what we have highlighted. Number one, what I am having as you contributed is sound. Number one we are having here is what we have we have what you have contributed. We have sound, we have carbon emission, we have lack of maintenance, and we have global warming. But here we have what is called decarbonization, no carbon emission. We have resilience, we have flexibility, we have cost saving, we have commercial viability, and we have security. Now let me give an instance of solar energy system, and we have a fuel powering a generating set for cost saving. Before you can set up a renewable energy at home, be it solar, for the number of load you are having, you can spend, though I am in Nigeria and I'm presenting in Nigeria, you can spend close to 80,000 for you to have it. But when you look at it, it's expensive, in which the same wattage that you want to get from solar, when you compare with it with generating set, you can see it is cheap. Because for generating set, I don't know for now, but let's assume that the rate of 50,000, you will have the same rate in which you can set up your solar. Now you can see what 30,000 naira difference. But when you now look at it, you start buying fuel and the rest. Fuel in Nigeria now, we know how it costs per liter. For the maintenance, you know how much you are spending on maintenance. You know how much, for the other aspect of pollution, you know how much it contributed to your health. But having the same wattage for a solar system, then you can see how much you'll be spending. Once you have the solar setup for a solar PV, research shows that one solar PV will last, will have a warranty you for 25 years, and probably for 100 years you should be able to use it. So you can see the difference, just that it is what, so that is where the cost saving is coming under advantages of renewable energy. Okay, types of renewable energy, like we have said earlier, we have biomass, geothermal, wind, hydroelectric, and solar. Okay, let us now discuss about solar energy system. So why am I picking solar energy system? Because it is the most common one that we can use to replace our non-renewable energy system we are using. Okay, for solar energy system, what are the components that you need for you to have it? Now before we look at the word solar, it comes from sun. Okay, so we need to understand some solar energy technologies. Okay, right in 19th century, we have a we have a very good scientist that we all know, Albert Einstein. He came up with a principle, and the principle is all what is known as photoelectric effect emission. Now when you look at photoelectric effect emission, what is this thing saying? What Albert Einstein was saying is that anytime a monochromatic beam of light is hitting a surface, then it's giving an ejected electron. Now this ejected electron can be in form of energy. So with this, then we can produce energy. Let us take it again. When a monochromatic beam of light, that is a light of high intensity, is hitting a metallic surface, then it is giving an ejected electron. As it's giving the ejected electron, then it's coming in form of energy. So that energy is what solar is using to generate its energy. Okay, how is it possible? Okay, we have people that they are in that come from the physics background and from the science background there. We already know that we have what is called a semiconductor that have the properties of both conductor and insulator. So for them to be a semiconductor, and for this semiconductor, we have majorly two types, silicon and germanium. So for silicon, we know that it is of 0.6 volts, and for germanium is 0.3 volts. Now this is what we are using to generate this solar PV that you are seeing here. Now for this solar PV, there is what is called cell before it come up to what we all known as solar PV. Why am I saying all this? For us to understand the physics behind it, and for us to be able to have a very clear picture of how solar energy works in case we want to divert into research. Okay, now let us now look at solar thermal system. Heat fluid for domestic hot water, that is one, because they are of two types. Heat fluid for domestic hot water pool space conditioning or concentrated design for power generation will give us solar thermal system, because that thermal simply means heat in that system. And secondly, solar electric or PV system, which is the most common thing that we are seeing here and there, generate electricity to supply dedicated load or interfaced with other electrical system. So that is for solar electric or what is called solar PV system. Now the resources of this is coming from sun. So that is where I'm having all this block diagram here, in which we have solar energy technologies, we have the solar heating and cooling, we have sun, we have photovoltaic PV, and we have concentrated solar power, CSP. Okay, so that is what we are having here. Okay, let us move on to the components of solar energy, so that in case we want to have our solar PV, what are the things that we need to understand? Okay, we have what is called standalone system of PV system. Don't forget that PV system is what? Photovoltaic system. For standalone system, we have off-grid operation, we have sizing based on electrical load. I will discuss more about this. Then we have interactive system, in which we have parallel operation with grid supplement power to on-site load. I will discuss more about, because I still have some slides to cover, and we explain better about what we mean by off-grid system and on-grid system, because one of the objective is that we should understand the difference between off-grid and on-grid system. Okay, so we now want to look at solar photovoltaic system itself. Like I said, that it is from from the theory that we all know that when a light is striking a metallic surface, like a sun striking a surface, then there is an ejected electron. Just what we are saying there. So for solar photovoltaic system are used in the production of electrical energy through sun rays. So they are capable of harnessing the radiation and heat from the sun. When you look at this, number one, it is renewable energy. Because as you are using it, then we are having high intensity of sun. Then it gives more energy. That is one. With what? It is soundless, not hearing any sound when it is producing this energy. Number two, PV system converts the solar energy coming from the sun into electrical energy using various components. I want us to, you can say I put red into this. I want us to get it right. PV system convert what? Solar energy into electrical energy using various components. So simply means that solar PV cannot be a standalone to give us the power supply, but also need other what? Other various components. We are going to discuss about the components the solar system need, so that you are listening to this presentation can also have a setup at home. So some of these components include photovoltaic cell, inverters, junction box, charge controllers, batteries, and cables. I will explain each and every one of these components for us to understand. Okay, so what are the components of solar energy system? Don't forget that this point is what? Convert solar energy into electrical energy using various components. So we discuss about these components in details. Okay, before I proceed, I hope it is I am not too fast. I hope I am not too fast, and can I proceed?
Yes,
Yes,
I
you can put.
Okay, thank you. Okay, so these are the components of PV system. Number one, photovoltaic cell. Don't forget from our theory that we have stated earlier, this is the photovoltaic cell which forms a solar panel. Number two, inverters. We have this inverter. A lot of people have been trying to mix things up. They said, I want an inverter at home. And you tell, even there are some people that will tell you, I need solar at home. For me, is a wrong English. Because when you say you need a solar at home, some people believe that it is only solar. Once you have the solar, then you have the full setup. No. So we understand the main reason why the battery is coming in here, the main reason why the UPS and inverter is coming in, and the main reason why we have this charge controller, and the main reason why we have, you can see this is a clean house. So that's why it is in green color. This is a clean house. That is no noise, no carbon emission. Then you have your what? You have your power supply. We also need what is called junction box. We need charge controller, we need battery, and we need cable. Now, the first one is what? Photovoltaic cell, which is the solar. Now, this solar panel, the way it works is that once the sun is producing, once there is light, then it is being ejected on this surface. Then it have an ejected electron, which is in form of what? Which is in form of energy. Okay. Now, when you look at this solar panel, it is something you can also install at home without not calling anyone. You can see two cables coming out of there. If you can notice my presentation. So, what sign are you seeing on my slide? The sign. Can we all see that?
Yeah, I can see. I think positive and negative sign there.
Good. So now the positive and negative of that solar PV is going to a charge controller, right? Now, this charge controller, it have a lot of components, though we still discuss more about charge controller because they are of two types. We have what is called pulse width modulation charge controller, PWM, and we have what is called MPPT charge controller, meaning maximum power point tracking charge controller. So they are of two types. But let us just assume that this is a charge controller. What's the function of this charge controller? The charge controller is like a motherboard connecting the solar PV, the inverter, and the battery together. Now, this charge controller will give you high efficiency of the solar PV. Now, that is about the charge controller. Let us now take a look at the inverter. Okay, in some houses, most especially what we are having in our design before is that most people use AC, meaning alternating current, meaning current that changes sinusoidally with respect to time. An example is NEPA light and the rest. So we can see AC bulb here and there. We can see AC socket. We can see different kind of AC appliances that we are having. Okay. So now, when you now look at solar PV is giving DC, meaning what? Direct current. Meaning what? Direct current. But for our AC load, we need what? Um we need AC for our AC load, not DC. Now this charge controller, we also have this DC input and it's giving out DC. But the inverter there is to convert the DC to what is called alternating current. So that's why you are now having what? AC load over here. I'm not saying that we cannot use DC load because there are some houses that use DC bulb, they use DC socket, they use most of their components or most of their appliances are of DC model. But for those that they are using AC and for those that they are using both, so in this case, we can come up with this design. The inverter will convert the DC coming from the solar PV, then it's converted to AC. Now, this AC is what it is what powering this house. Okay. Now we have the battery. The solar is charging the battery, one, and also you can also charge this battery with AC if you are having hybrid system. I want us to take that because we can remove this battery. Simply, it doesn't mean that this thing cannot work. It doesn't mean that we cannot have this setup at home. But the main reason why we are using the battery is to store the charges so that maybe if there is no light, maybe we have what is called on peak and we have what is called off peak. So off peak do comes based on your location. You know, if you are in northern part of Nigeria, you will experience these high sunlight, and it's going to take up to like till 5 p.m. before it go back to its position. But if you are in, there are some location in Nigeria that there you don't have that high intensity of sun. So in this case, you need battery. Or even if you are in north, you will still need battery at some time. Maybe you want to work at night. You know, at night there is no sun, so it simply means that you cannot work. So you are using the battery to store those charges. So that battery will now be feed in into the what, into the house. So this is the component of the solar PV. So now looking at this, we have discussed about photovoltaic cell, we have discussed about inverters, then the junction box. So junction box is just where you make your connection. That is where you connect them together. That is that about that. So the charge controller, I've explained that, and I've explained battery, and cables are used to what, to connect them together. So like you are seeing red and black. Okay. So now let us look at examples of solar PV. So for PV system, I will just make it fast so that we can complete this presentation on time. So for PV cell, we have three types, but for this presentation, I'm putting two. Though I will still include the third one once I proceed on my presentation. So we have what is called monocrystalline and polycrystalline. So I will explain better on this. But the third one is what is called thin film PV cell. But the main reason why I'm not putting it here is that they are not used for business. They are not used for businesses. They are not being good for what's it called, at home. But they are good for research. That is the third solar PV. But basically, we have these two, which is what, monocrystalline and polycrystalline. Okay, so now let us look at this mono and poly. Mono, to make cell for what, monocrystalline panel. Silicon is formed into bars and core into wafers, and this is for what, for poly. Okay, we have discussed about solar PV, so we need to discuss about inverter. In short, inverter is the what, is the component that converts the what, the direct current to alternating current, which I have explained again. So which I have explained before, and it can be used for AC load. Okay, so this is a typical example of inverters. Though for people that will register, because we are still going to roll out some courses on renewable energy, and it's part of those things that we are going to discuss. For people that want to enroll for the courses, you learn how to build your own inverters. But for now, you can also have a ready-made inverter. So this is an example of ready-made inverter. But if you may ask me, what's different between all these ready-made inverter and the one that you can construct yourself? If you build an inverter yourself, then it simply means that you can add a lot of features to it, like the temperature sensor to check the temperature of the inverter. If it is hot, then close it. You can do a lot of automation with it using your embedded system. But if you have the ready-made inverter, you cannot, the flexibility is not that much. So the only thing that you need is just to convert the what, to convert the DC to AC. So that is that about that for the inverter. Then this is a wiring system of the solar system. We have the solar PV going to the charge controller, going to the battery, to the inverter, and we have load. Because for solar charge controller, we have three outputs. We have two inputs and one, sorry, we have one input and two outputs. What do I mean by these inputs? You can see the solar panel is what, connected to this solar charge controller, then which can power your PC and the rest. So this is your laptop. Okay, so for inverter, we have on-grid tie inverters and off-grid inverters, and we also have hybrid inverters. So hybrid inverters, in hybrid inverter, you can use both solar to charge it, and the same time you can also use electricity to charge it. So that is the major difference between them. Okay, now like I said, that there is a slide that discuss about this charge controller, because if you want to have this setup, you also need to understand about charge controller. So number one point is that it's used for charge controller, used to control the amount of current coming in and out of the system. You know, I've explained about the major reason why we need this charge controller. Number one, the main function is that it is used for to control the amount of current coming in and out of the system. So if there is excessive current and the rest, the charge controller should be what, should be the one to be what, available for that. Okay, Now, the second point is that it consists of some sensors that aid in regulating voltage across the battery. So note, it's not that the charge controller is coming as a result of um, being connected to the solar panel alone. It also consists of some sensors that aid in what? In regulating the voltage across the battery so that you will not have it is not going to damage your battery. Let me give an instance. You know, when you look at our phones now, the Android phones that we are using or iPhones and the rest, once the once the charging is full, what will happen? It will stop charging. So all these things are incorporated in the solar charge controller so that if the battery is full, then what is going to happen is that it's going to cut it off, because if you keep on charging the battery, then it will definitely spoil the battery. So that is one of the advantages of having a charge controller. And thirdly, it protect the battery from what? Overcharging and high temperature. So that is the main function of the charge controller. So we have two type of charge controller. We have pulse width modulation charge controller and maximum power point tracking charge controller. If you ask me what's the difference between them, first difference is that cheap. PWM is cheap and maximum power point tracking is more advanced than PWM. Why is it more advanced? Because it has some aspect of artificial intelligence in maximum power point tracking. So for MPPT, it harvests your sun more than PWM. Let's give an instance of you are connecting your solar to your PWM, right? Okay. Now, the way it's going to harvest your sun is not the same rate MPPT will harvest your sun. So that is the major difference between PWM and maximum power point tracking system. Okay. Another component that we need to look at, okay, this is just PWM and this is just more studies about PWM. That is, in essence, is a switch that connects the solar array to a what? To a battery. The result is that the voltage of the array will be pulled down to near that of the battery. And the PWM charge controller is good, low cost, like I said earlier. Low what? Low cost for small system only. That's another thing that we need to take note. When solar cell temperature is moderate to high between 45 and 75 degrees Celsius. So you can only enjoy PWM in a what? In a small system. Okay, but this is the example of charge controller. It is very simple thing that even if you have it, then you can do a lot of work with it. Now, I want you to take note of this charge controller. These are the points in which you can connect your solar PV, your battery, and your DC load. These are the points. Also, do you notice this USB? Fine. This solar charge controller, they also come with some functionalities, like you connecting it with your system, like you connecting it with your phone for the sake of research or for the sake of monitoring some components in your system. Like there is a technology being called Internet of Things. That is, you monitor the rate at which the battery is being charged, everything using internet. So that is why you are having this USB. So this USB, you can connect it to your system. Maybe you want to obtain some values. You want to obtain, maybe as a researcher, maybe you want to work on the charge value, the current value, and the rest. So you can use USB, you connect it to your system to obtain those data. So that is the main reason why you are having this. And not only that, in fact, you can also use this USB to charge your phone. You know, phone use 5 volts, so you can use it to charge your phone. Okay, so this is MPPT charge controller. You can see the major difference. Now, MPPT controller will harvest more power from the what? From the solar array, unlike the PWM. So the performance advantage is substantial, 10% to 40% when solar cell temperature is below 45 degrees Celsius or very high, or when irradiance is very low. I want us to take note of that. So which means that if we have sun and the sun is not of high intensity, then MPPT can work more than PWM. So because it will harvest more power from the what? From the solar array. And I want you to take note of this thing that is in bold. It will adjust its input voltage to harvest the maximum power from the solar array and then transform this power to supply the varying voltage requirements of the battery plus load. Okay, now let's discuss about battery itself. Okay, now we all know the main reason why we are using battery. Why? Because in energy system we have on grid, we have off grid. For off grid system simply means that what if there is no sun Does that mean that you cannot use that system? So that is why it is called off-grid system. That is, when there is no sun, then you can use it. So when there is no sun, then the battery will come to play that major role. So that is why you are now having what? The energy storage. Do we get that? Unlike on-grid system. On-grid system is there is no battery. So can someone tell me when on-grid system will be working perfectly? On-grid system. Hello, hope I am not only here. Is anyone with me? Just say I.
Yeah, hi, sir. Hi.
Okay, so can we proceed?
Yes, sir.
Okay, now the question is, for off-grid system, we all say that it will work perfectly even if there is no sun, right? But for on-grid system, once there is no sun, then it simply means that what? It will not work, because it is what? On-grid system. That is when there is sun, that is when it can work. Okay. Now for the energy storage, we have the battery. So battery cell must be connected correctly to prevent damage to the entire system. So we have to what? Connect it very well. And in connecting your battery, we only have two types. Is either you connect it in series or you connect in parallel. Now I want you to take note of this. This is a series connection in which you have the positive connected to negative, positive connected to negative. If it is in parallel connection, do you have positive connected throughout and negative connected throughout? If you take an example of this battery, maybe 12-volt battery, then connect it together, you are going to observe a spark. So that is why you need to be very, very careful when connecting your battery. If not, it's going to damage all the entire system. So that is that about the battery. Okay, so this is series connection. So you can see positive connected to negative, then positive connected to negative, then this positive has been looped. So these are series parallel configure battery bank. So what's the meaning of this battery bank? When we have two or more batteries, then we can call it a battery bank. So this is a connection of, you can see both series and parallel connection, positive connected to positive, negative connected to negative, parallel connection, then we have series connection, positive to negative, positive to negative. Now, why do we need series and why do we need parallel? Now, if you go back to the theory of physics, anytime you connect battery in series, it's going to multiply your voltage, but you are going to have the same current flow. Let's take that again. For series connection, you have different voltage but the same current. That is, if I have 12 volts, I have 12 volts. I connect them in series, then it's going to give me 24 volts. But in parallel connection, you have you will have the same voltage but you have different current. So in parallel connection, if you connect it together in parallel, what is going to give you is what is the same. You are going to have very high amount of current but you have the same voltage. So if I connect two battery in parallel, if it is 12 volts, then I will have my 12 volt output but the current will be what? Will be multiplied. So that is why we need series, that is why we need parallel connection. Okay, so now we now have what is called smart meters. Now this smart meter is an electronics device that record the power consumption of an electric grid system and communicates the data to the electricity supply or distributor for monitoring and billing. Oilsflick is going to roll out a course on internet of things, and with internet of things embedded system you can design your own smart meter. Okay, so what this smart meter, like the word implied, meter, is just smart and it is what meter. It is smart because it has some aspect of embedded system and internet of things. So you can monitor, I can monitor the power outlet of, I can monitor the output power of this building with an Android application. I believe that we also come across something like that before. So you have your Android app, then you open it, you monitor the power consumption and the rest. So that is the main function of what? Of smart meter. And these are series of example of smart meters. So these are series of example of smart meter. So it's just to measure the power consumption. Because don't forget that we are still discussing about what? Clean energy and its components, but we focus on solar power, solar energy system, because that is one of the most common one that you can use to replace um generating set. Okay, so these are smart meter. We have bidirectional meter, which is a combination of a feed-in meter and a power meter in one device. Okay, so how does smart meter works? So smart meter record the current electricity flow at regular interval. Then the usage information is sent to a data to the data communication company. So this is how it works. After recording it, it send the information. Then your energy supplier then receive the information about the electricity usage. Then the electricity energy supplier, if this is the company that is supplying the energy, then they receive this information. Then an accurate energy bill is sent based on your consumption, which will help you to keep track. So after the energy that you have used, then these people will come and give you the what? The letter that okay, this is what you have used, you have to pay the what? You have to pay the money. So we also have smart meters. There are some houses that use smart meters. Yes. Okay. So now in short, we have a PV array. It convert the sunlight to what? Direct current. Don't forget I've mentioned that. So after converting it to direct current, we have a what? A charge controller. Number two, a charge controller protects the battery from what? Overcharging. This is the battery, and this is the battery bank. Now battery bank is like a combination of two or more battery, just like how would I call it? A container. Then you have your battery in it. So a battery bank stores the energy produced by the what? By the PV array. That is the sun that is coming from here, which is a form of energy. This guy will what? Will save it. Then we now have an inverter. Don't forget that this solar PV can also what? Charge this, can also be connected to this inverter. But also a battery bank is connected to this inverter because the inverter will now convert that DC to AC, which is what you want to use. Okay, then we have our what? We have our bulb. So we have our power meter, which measure how much electricity you use for your own and how much you send back to the grid. And number six, during the peak period and at night, electricity is imported from the what? Electric grid. Okay, so connecting the components. Now this is a good setup of what you can have. This is the battery, we have the cables, we have the solar, we have the charge controller, and we have the inverter. Okay, so these are ready made what? Ready made inverters. Okay, so I've discussed about off grid and on grid. I want you to pay notes, to take note of this. We have the off grid, in which you have the solar panel, you have the inverter, you have the battery bank. But in on grid system, there is no battery. That is, once there is sun, that is when you have the energy. Once there is no sun, then you don't have the energy. So you can see the what? The battery bank. Okay, so these are a very good setup of what you can add at home for on grid system. You have the sun on the solar PV, you have the MPPT charge controller, you have the inverter, then you have the smart meter, then you have distribution panel, in which you can connect your bulb, fan, and the rest. Like I said, so though we are almost through with the presentation, just this one will give a recaps. We have three type of solar panel. We have the monocrystalline, polycrystalline, and thin film crystalline. But basically, these two are being used. This one is for research purpose, but you can use this at home or at office. But which one is better? That is the question you want to ask. But the answer is the two are what? Are better. Just that you need to know when to use them. Okay, when do you know to use them? Now let us look at the comparison. Up to 20% efficiency, most expensive, made up of pure silicon, black color. Then this is the temperature. And for poly, this is what we are having for tin. Don't forget that I've already said that what this one is very good for what research. So that's why you are having what? Poor efficiency. But you can see this one has a very good efficiency, 20% more than the polycrystalline. Okay. But what of the price? We need to consider that. So now, presently, when you look at this, for polycrystalline of 330 watt 24 voltage, you have this to be the price in rupees and naira. You can see it is more expensive. Okay, mono is more expensive than polycrystalline. Okay, but like I said that you need to observe something. They are of the same power ratings. We have 330 watt, we have 380 watt 24 volt. But look at the voltage, look at the voltage. The current is 8668 and this one is 9.66. But let us just say these are what are the same thing for now. So, and what we can observe is that for the same wattage rating, polycrystalline module are larger in size. That is, you also need to compare the size. Then, in other words, monocrystalline modules are what space efficient. So, if you have a very small space, then you should go for what monocrystalline solar PV. Okay. So, how do we choose the one to use? If you have a very large space, then you use polycrystalline. Then, if you have a small size space, then you use monocrystalline. Like a student that want to set up an inverter system with solar at hostel, maybe at home, then in this case maybe if you have a small space, then you have to what to consider it. So that's why I said you can't say this one is the best, just that you need to understand why you are what you are using it. Okay. So how to choose a solar PV? So for commercial purpose you go for monocrystalline because they are what space efficient. And this is the last of the presentation. So these are the things that we need to consider. Number one, the roof size, area of availability. You know, if you rent house and you want to have this solar system and you want to use it to disturb your neighbor, you have to think about this also. So you have to consider the what, the area availability. Number two is the angle of your roof, because research has shown that where your solar PV is facing, we also have results on how it is going to harvest it. Do we get it? So that is that about that. The roof pitch, that is the angle of your roof. In fact, you will see some settings that they will have something like angle that will hang the solar PV itself. So they are also considering what the angle of the roof. Number three, we have what is called roof obstruction shading. Please, we need to take note of this anytime we are setting up a solar PV at home. Why? Because just like we have a pipe, if you have a pipe, just take a view about having a crack in that pipe. Will that pipe transform the water 100%? The answer is no. And that leakage can cause a lot of problem. So the same thing is applicable to solar system. Anytime you are having a shading, maybe there is a shade on one cell, because those cells are connected in series, and anytime you are having a series connection, just one can affect everything. So in this case, you have to place your roof or your solar PV in at a place that you will not have what is called shading, because shading will affect it. And also roof direction. A south facing roof is ideal for what solar panel. You have to take note of that roof direction. And also you need to consider the roof material. Roof material in the sense that the electrical wiring you are using, because when you look at a theory in physics, Ohm's law, you know, in Ohm's law, the um current is inversely proportional to the resistance. So now when you have a very long cable, maybe you are using your solar PV, but you are having a very long cable, it's going to affect the result you'll be having, because the length itself will affect the current at which it's going to transmit. So in this case, the electrical wiring is very, very important in terms of even the diameter have a result on it. Don't forget that there is a law in physics that we have giving us the resistivity of a conducting wire, connecting it with resistance and connecting it with length, and connecting with area, surface area. That is R equals to pro L over A. So we have the cross-sectional area that we need to take note of it. We have the length that we need to take note of it. So that is the roof material. And secondly, the climate, the climatic condition. We also need to take note of this. And the last one is the regulation. The last one is the regulation. So that is that about the clean energy focus on solar PV. Oilsplick is going to present more topics for tutorials on renewable energy, how to install it, then how to um, also go deep in renewable energy, because there is an aspect called there is a software called MATLAB Simulink. You can use MATLAB Simulink to do some simulation. So we are going to roll out courses on how to even have a very good understanding about solar PV. You know, what we just did, this presentation is just to cover your understanding and for you to set up at least one. So what if you want to build your own charge controller? You need research. What if you want to build your own inverter? So that's why you need the what? You need the tutorial, the advanced tutorial on it. So that is what I have for this presentation. Thanks to everyone for having the patience to this moment. And the floor will be open for questions.
Okay, everyone. Before we open